Ну, количество людей в зале, конечно, просто зашкаливает. Пятница. Собрались самые стойкие. Ладно, попробуем с пользой провести эти 45 минут, чтобы, да, не было обидно, потому что все остальные уже бухают и веселятся.
We'll be speaking about the 14.88 Mpps, the line rate for the 10 gigabit connection. Okay, so how we'll be able to process such packet rates, such high packet rates at the commodity hardware? Why did we actually decide to create such a presentation? In actual fact, here you can see the chart with all of the 7,500 incidents that we have observed since the beginning of 2012. These incidents, spoofed source incidents, and the other ones, and the dynamics is pretty straightforward. The spoofed source attacks account for more than 50% this year. Why? Why is this so? Because this is real convenient. Because normally they use the UDP flood. The UDP flood is very easy to generate. The UDP flood is back here. The DNS amplification is back with us. For amplification, we can use any UDP service. MTP, which is a popular service, and UDP is very easy to generate, so it's a popular tool, popular thing. There are different TCP-like floods and SYN floods, SYN floods for the ports that someone listens to, the ports that someone never listens to. ACK flood. ACK flood is normally used for exploiting the vulnerabilities. In the networking hardware. It has prospects. And there is yet another one. ICMP flood, Smurf. The favorite one, ICMP flood. ICMP8 is the classic way of making a DOS attack into a DDoS attack, distributed denial of service. L7 is out of style. Why? Because the arms race is ongoing, and people have so far been able to withstand the L7 attacks. They required the brains, and the attackers don't want to switch on their brains, so they prefer floods instead. Okay, UDP flood is attacking you and nothing is working, so who's to blame? Well, it's those idiots, idiot aliens are to blame, those who create these lines. TCP connections have been initialized, there's no data exchange, and they should still be living for 5 days. 5 days? Isn't it too long? Maybe we should make it 365 days instead. If you have some TCP connection tracking, please cross them all out, and close them all down. Okay, you have no connection tracking, but still you have a 100% CPU load. Your services are getting cold, nothing is working, nothing is online. So who else to blame? It's you to blame because you did not adjust your networking stack. What do we need to do here? So let's just take an average commodity hardware, Sandy Bridge-like. It's a Sandy Bridge-like server with the Intel controller, with the vanilla Linux running on it. It's a standard Intel networking network card driver that's using. First of all, we just put it in different kernels by using affinity. Apply to kernel. Some distributives prefer using NQ balancer, which is a bad idea. Totally bad idea, because every time the packet would be going to a different kernel, and the CPU cache won't have any metadata related to that. Affinity is much better. So you'd better use affinity. If you don't want to do it manually, you can do this. Use the scripts which can pull it off for you in a good way. The situation will become much better. Finally, the Intel will have the multi-threaded stack, and traffic will be loading all the cores of the CPU. The machine will be alive and running, but we can do it even better. We use the favorite stool command and use the -E sign and create the rule as on screen. Block every possible bit of the UDP traffic, and it will look just amazing. You will have some malicious traffic. CPU is not dedicated to tackling that traffic whatsoever, and all your networking services will be available. An excellent tool, excellent solution. How come that happened? We have a wonderful feature called Intel Flow Director. What's that like? Here's the Flow Director description. It's a set of filters which allows us to connect the flows to queues. Def0/. Memory-wise, the size of memory storing these filters is in the card's buffer. Later I'll explain why and how it works. The Flow Director has two types of filters that may be interesting for us. The first filter is the perfect match filter. It's clear what's it like. You maintain the fields. If there is a match, it goes where necessary. The second filter is less obvious. It's a signature filter for the fields we marked. So in memory we'll have more signature filters. 2,000 instead of 8,000, yet it poses a few limitations. We'll speak about those later. So what can this flow filter do? As we can see from its definition, this flow filter has a source destination ports, and also we have the flexible 2-byte tuple anywhere in the first 64 bytes of a frame. Why wouldn't everyone use it? It looks so good, but it's not perfect. Intel had not created that product as a firewall solution. It was intended for different needs, for Intel needs. Intel was trying and connecting the IP client to the exact kernel to enhance the performance of CPU cache. That's where all the problems stem from. We use quite a lot of RX buffer memory. We can use 256 out of 512 megabytes of memory. The filters have no if-then logic. If masks are global for signature filters, masks are global for signature filters, by default all the filters will be assigned the /32 masks. The signature filters should be used only if for some reason if you have the performance degrading. And the last one, but it's a painful one, is the depth of the package, 64 bits. It's very small. It supports the Eth tool. The Eth tool works with perfect match filters, and it has plenty of bugs. In the next 6 months, it will be fixed, I believe. We have so far been not able to make it work otherwise. The DF-ring also works here. It works with signature filters. So there are some deficiencies, of course, but we would like to thank Intel anyway, because we have it in the controller thanks to Intel, and it's good that we have it in the open access, and it is all stipulated in the guidelines how to program those filters. Yet there is another very interesting feature called flex filters. They were established a bit earlier than flow directors, and I believe Intel was trying and looking for the implementation of their access, and the actual depth of the filter is not 64 bytes, it's 128 bytes. There are 6 of them available on the controller, which have their own deficiencies and drawbacks. They would go on and off when you try to update them, so Please remember that as security filters they will not go here, and they don't have the publicly available user-land interface. You may of course read the guidelines about programming those filters. And the second guideline, you may ask Dmitry Popov to publish our user-land utilities. So far we have not done it, been too modest basically. Okay, the next point. What do we do with the TCP SYN attacks, TCP SYN? What do we do with them using these filters? The attackers sometimes make trivial errors, mistakes, send SYN packets without sequence numbers, or with very identical with an identical sequence numbers, or without MSS. Normal clients will never do that, of course. So everywhere we can put a signature and filter it. You can filter out such attacks, and it actually works very quickly. Next question, what do we do with the SYN flood, SYN flood, where it would be hard to identify the signatures, yet we have to filter it? Well, some people say SYN cookies should be on. Well, if you put it on, you will be just dying painfully at 400 kilopackets. So who's to blame? And what do we do here? But the profile analysis, what's the standard kernel is doing? Seems like 98, 94% is in here. TCP v4, TCP IP v4. SYN cookie was something that allowed us to initiate the second step of TCP connection without dedicating resources on the server. It's a good idea. Yet there is one thing to blame, is the SYN flood identifiers to blame. It's the code to blame which activates the TCP cookie transactions, which stays there and is a redundant and reluctant function, and MD5 SUM. So what do? We would like to survive, of course. In this case, we suggest a more innovative support. What if we create so many IPs like this, like I'm showing here on the slide? Somehow dashes would not show here, all the flags are here without dashes. Seems like that if when we do so, life gets easier. We reach 2.5 Mpps without using any other external tools. Isn't it great? How many more minutes do I have? Because I'm basically done. Oh, you still have time. Okay. What do we do if we send a SYN packet to the port that no one's listening? Do you know what happens in this case? there will be RST. What if we send way too many packets there to the port that no one's listening to?
Будет вот так вот.
It will look like this.
До тех пор, пока количество RSS у нас работает в пределах одного процессора, мы будем затыкаться где-то на 400.
Will be blocked at 400, 500 megapackets, and then the core will be dead. Do you know why?
Потому что тут тоже логика. Причем написано, наверное, не очень чисто.
Because there's also something real dirty in here,
О чем это говорит? Это говорит о том, что люди
which explains the fact that people
многие вещи
who write lots of things in the kernel live on a different planet, or rather in a different universe. It seems like that they're not worried about getting too many packets till they get down to reality. We don't actually need the 5 days of timeout that I described earlier. Who else could have done it? Aliens only.
Оказывается, помимо инопланетян,
But apart from those aliens, there are some good guys working. And a year ago, they just removed that fail out of there. And now, Linux kernel works like this.
то есть 3,5 не хватит.
3.5 megapackets. It's very good and reliable.
Если вы шлете с одним и тем же айпишником, мне ничего не мешает.
If you send it with the same IP, I can use this same filters and ban this IP. And I'll just simply ban it.
У меня есть 32 PHDays. Для того, чтобы эти ваши несколько айпишников постоянно заблокировать.
I can easily block those few IP addresses that you send traffic from.
Секундочку. Теперь давайте поговорим про
Just 1 second, hold on. Let's just speak about botnet. Let me ask you a question. You seem to know a lot, right? So what do you think? Why do you think the attackers seem to use this software for attacks so much?
Ботнеты выросли, не соглашусь. Вот если, к сожалению, у меня здесь нет этого слайда, но если было в других отчетах,
I'm missing this slide that I wanted to show you here in the
среднего размера ботнета,
presentation, but the average botnet size,
средний размер ботнета,
the average botnet size is reducing year after year, because there are plenty of ways of monetizing botnets. There are plenty of tools available of how to create your own botnet. You have source code for creating botnet. You know it well. There are plenty of schoolboys who would like to create their own botnets. Zillions of schoolboys and girls who would like to create their botnets. The average size of a botnet is reducing, and we have not seen huge botnets for a long time. For one final year, the maximum botnet was 150.
Какой? Там конкурент.
150 hosts. And that one that you mentioned had no competition. That's why they were able to come up with 600. That was a good one. Just an exception, rather, which proves the general rule. Botnets are getting smaller. So, why was I explaining all that stuff? It's Friday, it's getting late. Please do use the Intel tools. It's great that they have them. And they have disclosed the specification, and we don't need to poke our noses there on our own. Do you have any other questions?
Ну, смотри.
Well, it cost furor last year. Nitmap, developed for FreeBS, was ported to Linux, pflink, and a real ugly thing, Pocket Gen. It works well, shows great numbers, generating. From one node, you can easily generate a line rate, easily.
Это было тонко, да, я просто спешил написать заявку. Конечно, речь идет про обычные Intel AMD 64.
Yeah, AMD 64 is the right name of the architecture that you're referring to. Itanium is still on market. It's sold successfully, not to us. We don't buy it.
Про Windows мы...
Windows is a question regarding Windows. Windows is a terra incognita for us. Sometimes there are some things with NDS and other things. We don't know much about it. No comment about Windows.
Нет, есть уверенность, что вот
I think that series of attacks, which was DNS amplification, it was a small botnet created from nice servers, approximately 150 of them. It was proved that it was WordPress which did it well. You see, Windows, Linux, let's talk about deficiencies, deficiencies of Windows. For such attacks, it's not just a huge packet rate which is important, it's the infrastructure that should carry this packet rate to the victim. With the ADSL, you cannot expect it. We had a huge Vietnamese bot attacking Russia, and when we published the numbers, people were just making jokes about, you see, such a huge botnet should have killed all the Russian internet in Russia. It might have killed it if Vietnamese colleagues had a huge throughput capacity, bandwidth, that they did not have enough bandwidth. What you are referring to, I cannot comment what you are referring to. People just cannot configure their DNS servers. That's number one. Who holds the resolvers? Who has request rate per IP on a resolver? You do, others don't. That's typical. Yandex-like resolvers was a good mechanism for diluting the attack, very quickly and efficiently connected to the network. The principal difference from what we had in 2010 and now, in 2010 we had a specially dedicated zone. We're looking for the resolvers with the recursion open, and those resolvers had been sent to the victim. And this year it's smaller in size. There are approximately 50 of those, and we used TXT. With Yandex, it was not needed to use TXT records. They use IPv6 SPDIF. And DNSSEC, imagine DNSSEC, a piece of luxury.
Не, без амплификации.
Without amplification. Imagine you have a server which is nicely connected and you would like to kill someone seriously. You may generate ICMP directly, but the vector will be obvious. Or you can spread the packets in a different way. Make a distributed attack, if you like.
Еще?
Do you have any other questions? I think it's time for drinks.
Там не только Wi-Fi, там еще NTP сервера локальные, вообще море боли. Можно сгенерировать и будут генерировать. И будут генерировать. Смотри, основная проблема с текущей ситуацией, сеть вообще позволяет пропускать через себя пакеты с фейковыми адресами. Хотя, в принципе, гайдлайны, соответствующие этого, были написаны там.
Fake addresses are supported, although the guidelines were created a few years earlier, but there are some other nasty guys called telecom providers. Whenever I'm announcing this at telecom meeting, sometimes they get very offended. One person was trying to explain that they have a very complicated topology of a network, and telecom guys don't like working. DNS amplification, what's so interesting about that? Because the first attack was noticed in March. 2.6 gigabits, I'm sorry, 20-30 gigabits, then it doubled in size, then it doubled again, and when it reached 120, we got a little bit scared of and surprised. And afterwards, the RUNET had problems. Rustel and Transtel were hurt. No one wrote any stories about that. Seems like they were trying to delete some porn materials and other things that they didn't want to make public. Spam house, for instance. I'm not sure that those who declared that order were related to that. You see? Spam house.
Вместе с порнотой и всяким прочим ротанком. Еще вопрос? Ну а что там, UDP разогнанный DNS amplification. Ну, какая разница, какие там детали? Ну вот какая мне польза от того, что я знаю, что это TXT филд для фейкового зарегистрированного домена? Да они с таким же успехом могли вот и у Яндекса поспрашивать. Яндекс, кстати, ввел rate limiting. Рекомендую всем остальным держателям резолверов ввести rate limiting. Ну и вообще, общее правило, если у вас есть UDP-шные сервисы, пожалуйста, посматривайте в ту сторону. Интересная деталь. Я когда стонал в фейсбучике у себя по поводу вот этих плохих DNS-серверов, есть такой сетевой персонаж в России, Алекс Тутубалин. Вот он, оказывается, тоже держит свой DNS-резолвер, И он пошел, посмотрел, собственно говоря, свой трафик месячный по этому резолверу и шибко удивился. Вот. Хотя, в принципе, технически достаточно грамотный человек. Еще вопрос? У тебя тоже есть резолвер? Вот. А домашние вещи такие с деплоем массовым, там же деплоят комбайны, у них точно есть NTP встроенный, скорее всего не погашенный. Вот. Потенциально будет много боли. Вот на следующей неделе в Питере будет еног, попробуем там поговорить еще раз с операторами. Ну, по крайней мере, сам Ростелек, ему тоже досталось, там группа безопасности настроена очень серьезно. Ну, вопрос, насколько этой серьезности хватит. На месяц, на два, потом забудут. Угу. Только в следующий раз там...
What about next time? Next time it will be even bigger, I think. Do you have any other questions? Well, we are done. Thank you very much. That's all.